So this process starts with G3P, which acts as a backbone for triglycerides and is resulting from glycolysis. Free fatty acids are activated to fatty acyl-CoA and acyl-CoA synthetase. The activated fatty acids go through a sequence of enzyme reactions. The first fatty acid is attached is forming lysophosphatidyllic acid. The second free fatty acid attached forms phosphatidic acid. This will then get phosphorylized, removing the phosphate and forming DAG, and then the third fatty acid will combine and form a triglyceride. The triglycerides are then stored in the adipose tissue for later energy use. So, two long-term factors that will regulate this process include high carbohydrate and fat intake and insulin activation. So, insulin will activate lipogenetic enzymes. So, it's the enzyme for the enzymes, which then will catalyze this reaction. So, insulin is a enhancer for this. High carbohydrate and high fat intake will also increase triglyceride synthesis, because you're putting more sugar in the body or more fat in the body, which then can be turned into triglycerides. Short-term regulation will include hormones such as insulin, glucagon, and epi and norepi, and then also glucose availability. Insulin will catalyze triglyceride synthesis by increasing glucose uptake. Basically, you're putting more fat and more glucose into the body, which then can be turned into triglycerides. And then glucagon and epi and norepi will inhibit this by promoting lipolysis or the breakdowns of fat. Glucose availability goes with the first one. When you have glucose, you won't need to put more glucose into the body, so those won't be turned into triglycerides.